Learning objectives. In this lesson, you will be learning about basics of C++, elementary data structures, arrays, linked lists, and the following in detail. Basics of C++, object-oriented programming, representation of arrays, application of arrays, stacks and queues, application of stacks, pointers, linked list. Basics of C++. C++ is a statistically typed, compiled, general-purpose, case-sensitive, free-form programming language that supports procedural, object-oriented, and generic programming. C++ is regarded as a middle-level language as it comprises a combination of both high-level and low-level language features. C++ was developed by Bjarne Trostrup starting in 1979 at Bell Labs in Murray Hill, New Jersey, as an enhancement to the C language and originally named C with classes, but later it was renamed C++ in 1983. C++ is a superset of C, and that virtually any legal C program is a legal C++ program. The ANSI standard is an attempt to ensure that C++ is portable, that code you write for Microsoft's compiler will compile without errors using a compiler on a Mac, Unix, a Windows box, or an Alpha. The ANSI standard has been stable for a while, and all the major C++ compiler manufacturers support the ANSI standard. Basic syntax. Object. Objects have states and behaviors. Example, a dog has states, color, name, breed, as well as behaviors, wagging, barking, eating. An object is an instance of a class. Class. A class can be defined as a template or blueprint that describes the behaviors or states that objects of its type support. Methods. A method is basically a behavior. A class can contain many methods. It is in methods where the logics are written, data is manipulated, and all the actions are executed. Instant variables. Each object has its unique set of instant variables. An object's state is created by the values assigned to these instant variables. C++ program structure. The C++ language defines several headers which contain information that is either necessary or useful to your program. For this program, the header IO stream is needed. The line using namespace std tells the compiler to use the std namespace. Namespaces are a relatively recent addition to C++. The next line /main is where program execution begins. Is a single-line comment available in C++? Single-line comments begin with 2/ and stop at the end of this line. The line int main is the main function where program execution begins. The next line COUT causes the message, "This is my first C++ program," to be displayed on the screen. The next line return 0 terminates main function and causes it to return the value 0 to the calling process. Compile and execute C++ program. Open a text editor and add the code as above. Save the file as hello.cpp. Open a command prompt and go to the directory where you saved the file. Type g++ hello.cpp and press enter to compile your code. If there are no errors in your code, the command prompt will take you to the next line and would generate a.out executable file. Now type a.out to run your program. You will be able to see Hello World printed on the window. C++ identifiers. Manpower. A C++ identifier is a name used to identify a variable, function, class, module, or any other user-defined term. An identifier starts with a letter A to Z or small case a to small case z or an underscore followed by 0 or more letters, underscore and digits 0 to 9. Manpower. C++ does not allow punctuation characters such as ampersand, dollar, and percentage within identifiers. C++ is a case-sensitive programming language. Thus, manpower with M in capital and manpower with M in small case are two different identifiers in C++. Trigraphs. Trigraphs are expanded anywhere they appear, including within string literals and character literals, in comments, and in preprocessor directives. White space in C++. A line containing only white space, possibly with a comment, is known as a blank line, and C++ compiler totally ignores it. Comments in C++. C++ supports single-line and multi-line comments. All characters available inside any comment are ignored by C++ compiler. C++ comments start with /* and end with */. Data types. C++ offer the programmer a rich assortment of built-in as well as user-defined data type. The basic types can be modified using one or more of these type of modifiers: signed, unsigned, short, long. Data types. Type DEF declarations. Type DEF, type new name. For example, the following tells the compiler that feet is another name for int. Type define feet. Now the following declaration is perfectly legal and creates an integer variable called distance, feet distance. Data types. Enumerated types. To create an enumeration, it requires the use of the keyword enum. The general form of an enumeration type. Syntax. Enum num name. List of names, variable list. Here, the enum name is the enumeration's type name. The list of names is comma separated. For example, the following code defines an enumeration of colors called colors and the variable C of type color. Finally, C is assigned the value blue. Syntax. Enum color within brackets red, green, blue, C equals blue. Configuration. Syntax. Enum color red, green equals phi, blue. White on green. Here blue will have a value of 6 because each name will be one greater than the one that precedes it. Variables. C++ also allows to define various other types of variables which we will cover in subsequent chapters like enumeration, pointer, array, reference, data structures, and classes. Variables. Variable definition in C++. A variable definition means to tell the compiler where and how much to create the storage for the variable. A variable definition specifies a data type and contains a list of one or more variables of that type. Type variable underscore list. Float consists of digits, plus or minus, and or a decimal point. Occupies 4 bytes. Double, special float that store more significant digits, occupies 8 bytes. Character, single letter, digit, punctuation mark or control symbol. Void, useless. Here, type must be a valid C++ data type including character, W_char, int, float, double, bool, or any user-defined object, etc. And variable underscore list may consist one or more identifier names separated by commas. Some valid declarations are shown here. Variables. Variable definition in C++. A variable declaration provides assurance to the compiler that there is one variable existing with the given type and name so that compiler proceed for further compilation without needing complete details about the variable. A variable declaration has its meaning at the time of compilation only. Compiler needs actual variable declaration at the time of linking of the program. L values and R values. L value. An expression that is an L value may appear as either the left-hand or right-hand assignment. R value. An expression that is an R value may appear on the right but not left-hand side of an assignment. Variable scope. A scope is a region of the program, and broadly speaking there are three places where variables can be declared. Inside a function or a block, which is called local variables, in the definition of function parameters, which is called formal parameters, outside of all functions, which is called global variables. Local variables. Variables that are declared inside a function or block are local variables. They can be used only by statements that are inside that function or block of code. Local variables are not known to functions outside their own. Global variables. Global variables are defined outside of all the functions, usually on top of the program. The global variables will hold their value throughout the lifetime of your program. A global variable can be accessed by any function. That is, a global variable is available for use throughout your entire program after its declaration. Constants. Constants refer to fixed values that the program may not alter, and they are called literals. Integer literals, floating point literals, Boolean literals, string literals, character literals. Constants. There are two simple ways in C++ to define constants. Using #define preprocessor, using const keyword. Integer literals and floating point literals. An integer literal can be a decimal, octal, or hexadecimal constant. A prefix specifies the base or radix, 0x or 0X for hexadecimal, 0 for octal, and nothing for decimal. Floating point literals. A floating point literal has an integer part, a decimal point, a fractional part, and an exponent part. You can represent floating point literals either in decimal form or exponential form. Boolean literals. There are two Boolean literals and they are part of standard C++ keywords. A value of true representing true, a value of false representing false. You should not consider the value of true equal to 1 and value of false equal to 0. String literals. You can break a long line into multiple lines using string literals and separate them using white spaces. Character literals. Character literals are enclosed in single quotes. If the literal begins with L uppercase only, it is a wide character literal. Example, LX, and should be stored in W character _T type of variable. Otherwise, it is a narrow character literal, example X, and can be stored in a simple variable of char type. Modifiers. There are C++ allows the character, int, and double data types to have modifiers preceding them. A modifier is used to alter the meaning of the base type so that it more precisely fits the needs of various situations. The data type modifiers are listed here. Signed, unsigned, long, short. Type qualifiers in C++. Constant. Objects of type constant cannot be changed by a program during execution. Volatile. The modifier volatile tells the compiler that a variable's value may be changed in ways not explicitly specified by the program. Restrict. A pointer qualified by restrict is initially the only means by which the object it points to can be accessed. Only C99 adds a new type of qualifier called restrict. Storage classes in C++. The external storage class. The external storage class is used to give a reference of a global variable that is visible to all the program files. When you use extern, the variable cannot be initialized as all it does is point the variable name at a storage location that has been previously defined. The mutable storage class. The mutable specifier applies only to class objects. Storage classes in C++. Auto, register, static, extern, mutable. Storage classes in C++. The register storage class. The register storage class is used to define local variables that should be stored in a register instead of RAM. This means that the variable has a maximum size equal to the register size, usually one word, and can't have the unary AND operator applied to it, as it does not have a memory location. The static storage class. The static storage class instructs the compiler to keep a local variable in existence during the lifetime of the program, instead of creating and destroying it each time it comes into and goes out of scope. Therefore, making local variables static allows them to maintain the values between function calls. Operators. Arithmetic operators. Relational operators. Logical operators. Bitwise operators. Assignment operators. Miscellaneous operators. Arithmetic operators examples. Plus adds two operands. Minus subtracts second operand from the first. Star multiplies both operands. / divides numerator by denumerator. Percentage, modulus operator and remainder of after an integer division. ++, increment operator increases integer value by 1. -, decrement operator decreases integer value by 1. Relational operators examples. Equals. Check if the value of two operands are equal or not. If yes, then condition becomes true. Exclamation equals. Checks if the values of two operands are equal or not. If values are not equal, then condition becomes true. Greater than. Checks if the value of left operand is greater than the value of right operand. If yes, then condition becomes true. Lesser than. Checks if the value of left operand is less than the value of right operand. If yes, then condition becomes true. Greater than equal to. Checks if the value of the left operand is greater than or equal to the value of right operand. If yes, then condition becomes true. Lesser than equal to. Checks if the value of the left operand is less than or equal to the value of the right operand. If yes, then condition becomes true. Logical operators. Logical AND operator. If both the operands are non-zero, then the condition becomes true. Logical OR operator. If any of the two operands is non-zero, then condition becomes true. Logical NOT operator. Used to reverse the logical state of its operand. If a condition is true, then logical NOT operator will make it false. Bitwise operators. Binary AND operator copies a bit to the result if it exists in both operands. Binary OR operator copies a bit if it exists in either operand. Binary XOR operator copies the bit if it is set in one operand but not both. Binary ones complement operator is unary and has the effect of flipping bits. Binary left shift operator. The left operand's value is moved to the left by the number of bits specified by the right operand. Binary right shift operator. The left operand value is moved to the right by the number of bits specified by the right operand. Assignment operators. Simple assignment operator assigns values from right side operands to the left side operand. add and assignment operator. It adds right operand to the left operand and assigns result to the left operand. Subtract and assignment operator. It subtracts right operand from the left operand and assigns the result to the left operand. Multiply and assignment operator. It multiplies the right operand with the left operand and assigns the result to the left operand. Divide and assignment operator. It divides the left operand with the right operand and assigns the result to the left operand. Modulus and assignment operator. It takes modulus using two operands and assigns the result to the left operand. Left shift and assignment operator. Right shift and assignment operator. Bitwise and assignment operator. Bitwise exclusive OR and assignment operator. Bitwise inclusive OR and assignment operator. Miscellaneous operators examples. Size of. Size of operator returns the size of a variable. For example, size of A, where A is an integer, will return 4. Condition X, Y. Conditional operator. If condition is true, then it returns value X, otherwise value Y. Comma operator causes a sequence of operations to be performed. The value of the entire comma expression is the value of the last expression of the comma-separated list. Dot and arrow. Member operators are used to reference individual members of classes, structures, and unions. Cast. Casting operators convert one data type to another. For example, integer of 2.2000 would return 2. And. Pointer operator AND returns the address of an variable. For example, AND A will give actual address of the variable. Asterisk pointer operator. Asterisk is a pointer to a variable. For example, asterisk variable will pointer to a variable var. C++ loop types. Programming languages provide various control structures that allow for more complicated execution paths. A loop statement allows us to execute a statement or group of statements multiple times, and following is the general form of a loop statement in most of the programming languages. C++ loop types. While loop repeats a statement or a group of statements while a given condition is true. It tests the condition before executing the loop body. For loop execute a sequence of statements multiple times and abbreviates the code that manages the loop variable. Do while loop. Like a while statement except that it tests the condition at the end of the loop body. Nested loops use one or more loop inside any other while, for, or do while loop. C++ loop types. Loop control statements. Loop control statements change execution from its normal sequence. When execution leaves a scope, all automatic objects that were created in that scope are destroyed. Break statement. Continue statement. Go-to statement. Infinite loop. A loop becomes infinite loop if a condition never becomes false. The for loop is traditionally used for this purpose. Since none of the three expressions that form the for loop are required, you can make an endless loop by leaving the conditional expression empty. C++ decision making. C++ programming language provides the following types of decision-making statements. If statement, if-else statement, switch statement, nested if statements, nested switch statements. C++ decision making. C++ programming language provides following types of decision-making statements. If statement. An if statement consists of a Boolean expression followed by one or more statements. If-else statement. An if statement can be followed by an optional else statement which executes when the Boolean expression is false. Switch statement. A switch statement allows a variable to be tested for equality against a list of values. Nested if statements. You can use if or else if statement inside another if or else if statements. Nested switch statements. You can use one switch statement inside another switch statement. The question mark operator. The value of a question mark expression is determined like this. exp1 is evaluated. If it is true, then exp2 is evaluated and becomes the value of the entire question mark expression. If exp1 is false, then exp3 is evaluated and its value becomes the value of the expression. Functions. A function is a group of statements that together perform a task. Every C++ program has at least one function, which is main, and all the most trivial programs can define additional functions. A function declaration tells the compiler about a function's name, return type, and parameters. A function definition provides the actual body of the function. A function is known as with various names like a method or a subroutine or a procedure, etc. Defining a function. The general form of a C++ function definition is as follows. A C++ function definition consists of a function header and a function body. Here are all the parts of a function: return type, function name, parameters, function body. Function declaration. A function declaration tells the compiler about a function name and how to call the function. The actual body of the function can be defined separately. A function declaration has the following parts: return underscore type function underscore name of parameter list. Calling a function. When a program calls a function, program control is transferred to the called function. A called function performs defined task, and when its return statement is executed or when its function ending closing brace is reached, it returns program control back to the main program. To call a function, pass the required parameters along with function name, and if a function returns a value, then store returned value. Function arguments. If a function is to use arguments, it must declare variables that accept the value of the arguments. These variables are called the formal parameters of the function. The formal parameters behave like other local variables inside the function and are created upon entry into the function and destroyed upon exit. While calling a function, there are two ways that arguments can be passed to a function: call by value, call by reference. Call by value, call by reference. By default, C++ uses call by value to pass arguments. In general, this means that code within a function cannot alter the arguments used to call the function, and above-mentioned example, while calling max function, used the same method. Arrays. C++ provides a data structure, the array, which stores a fixed-size sequential collection of elements of the same type. An array is used to store a collection of data, but it is more often useful to think of an array as a collection of variables of the same type. All arrays consist of contiguous memory locations. The lowest address corresponds to the first element and the highest address to the last element. Arrays are important to C++. Multidimensional arrays. C++ supports multidimensional arrays. The simplest form of the multidimensional array is the two-dimensional array. Pointer to an array. Generate a pointer to the first element of an array by simply specifying the array name without an index. Passing arrays to functions. Pass to the function pointer to an array by specifying the array's name without an index. Return array from functions. C++ allows a function to return an array. Strings. String function and purpose. String cpy of s1, s2 copies string s2 into string s1. String cat of s1, s2 concatenates string s2 onto the end of string s1. String len of S1 returns the length of string S1. String cmp of S1, S2 returns 0 if S1 and S2 are the same, less than 0 if S1 lesser than S2, greater than 0 if S1 greater than S2. String chr of S1, ch returns a pointer to the first occurrence of character ch in string S1. String str of S1, S2 returns a pointer to the first occurrence of string S2 in string S1. Pointers. C++ pointers are easy and fun to learn. Some C++ tasks are performed more easily with pointers, and other C++ tasks such as dynamic memory allocation cannot be performed without them. A pointer is a variable whose value is the address of another variable. Like any variable or constant, you must declare a pointer before you can work with it. The general form of a pointer variable declaration is type star var name. Pointers. Pointers have many but easy concepts, and they are very important to C++ programming. There are following few important pointer concepts which should be clear to a C++ programmer. C++ null pointers. C++ supports null pointer, which is a constant with a value of 0 defined in several standard libraries. C++ pointer arithmetic. There are 4 arithmetic operators that can be used on pointers: plus plus, minus minus, plus minus. C++ pointers versus arrays. There is a close relationship between pointers and arrays. C++ array of pointers. You can define arrays to hold a number of pointers. C++ pointer to pointer. C++ allows you to have pointer on a pointer and so on. Passing pointers to functions. Passing an argument by reference or by address both enable the passed argument to be changed in the calling function by the called function. Return pointer from functions. C++ allows a function to object-oriented programming. C++, classes and objects. A class is used to specify the form of an object, and it combines data representation and methods for manipulating that data into one neat package. The data and functions within a class are called members of the class. Concept: class member functions. A member function of a class is a function that has its definition or its prototype within the class definition like any other variable. Class access modifiers. A class member can be defined as public, private, or protected. By default, members would assume as private. Constructor and destructor. A class constructor is a special function in a class that is called when a new object of the class is created. A destructor is also a special function which is called when created object is deleted. C++ copy constructor. The copy constructor is a constructor which creates an object by initializing it with an object of the same class which has been created previously. Concept: C++ friend functions. A friend function is permitted full access to private and protected members of a class. C++ inline functions. With an inline function, the compiler tries to expand the code in the body of the function in place of a call to the function. This pointer in C++. Every object has a special pointer, this which points to the object itself. Pointer to C++ classes. A pointer to a class is done exactly the same way a pointer to a structure. In fact, a class is really just a structure with functions in it. Static members of a class. Both data members and function members of a class can be declared as static. Encapsulation. Encapsulation is an object-oriented programming concept that binds together the data and functions that manipulate the data and that keep both safe from outside interference and misuse. Data encapsulation led to the important OOP concept of data hiding. Data encapsulation is a mechanism of bundling the data and the functions that use them, and data abstraction is a mechanism of exposing only the interfaces and hiding the implementation details from the user. All C++ programs are composed of the following two fundamental elements. Program statements, code. This is the part of a program that performs actions and they are called functions. Program data. The data is in the information of the program which affected by the program functions. Abstraction. Data abstraction refers to providing only essential information to the outside world and hiding the background details, that is, to represent the needed information in program without presenting the details. Data abstraction is a programming and design technique that relies on the separation of interface and implementation. In C++, we use classes to define our own abstract data types. You can use the COUT object of the class OStream to stream data to standard output. Access labels enforce abstraction. Members defined with a public label are accessible to all parts of the program. The data abstraction view of a type is defined by its public members. Members defined with a private label are not accessible to code that uses the class. The private sections hide the implementation from code that uses the type. Benefits of data abstraction. Class intervals are protected from inadvertent user-level errors, which might corrupt the state of the object. The class implementation may evolve over time in response to changing requirements or bug reports without requiring change in user-level code. Inheritance, base and derived classes. A class can be derived from more than one classes, which means it can inherit data and functions from multiple base classes. To define a derived class, a class derivation list to specify the base class, ES. A class derivation list names one or more base classes and has the form class derived class, access specifier base class. Access control and inheritance, constructors, destructors, and copy constructors of the base class. Overloaded operators of the base class. The friend functions of the base class. Types of inheritance. When deriving a class from a base class, the base class may be inherited through public, protected, or private inheritance. The type of inheritance is specified by the access specifier as explained. We hardly use protected or private inheritance, but public inheritance is commonly used. While using different type of inheritance, following rules are applied. Public, protected, private. Polymorphism. The word polymorphism means having many forms. Typically, polymorphism occurs when there is a hierarchy of classes and they are related by inheritance. Virtual function. A virtual function is a function in a base class that is declared using the keyword virtual. Defining in a base class a virtual function with another version in a derived class signals to the compiler that we don't want static linkage for this function. Pure virtual functions. It's possible that you would want to include a virtual function in a base class so that it may be redefined in a derived class to suit the objects of that class, but that there is no meaningful definition you could give for the function in the base class. Overloading. C++ allows you to specify more than one definition for a function name or an operator in the same scope, which is called function overloading and operator overloading respectively. An overloaded declaration is a declaration that had been declared with the same name as a previously declared declaration in the same scope, except that both declarations have different arguments and obviously different definition implementation. Operator overloading in C++. Overloaded operators are functions with special names the keyword operator follows by the symbol for the operator being defined. Like any other function, an overloaded operator has a return type and a parameter list. Box operator plus of constant box and declares the addition operator that can be used to add two box objects and returns final box object. Most overloaded operators may be defined as ordinary non-member functions or as class member functions. In case we define above function as non-member function of a class, then we would have to pass two arguments for each operand as follows. Representation of array. Array is a data structure that represents a collection of the same types of data. Declaring array variables. Method 1. Data type array ref variable. Example, double my list. Method 2. Data type array reference variable. Example, double my list. Creating arrays. Array ref variable equals new data type of array size. Example, my list equals new double of 10. My list of 0 references the first element in the array. My list 9 references the last element in the array. Declaring and creating in one step. Applications. Arrays are used to implement mathematical vectors and matrices as well as other kinds of rectangular tables. Many databases, small and large, consist one-dimensional arrays whose elements are records. Arrays are used to implement other data structures such as heaps, hash tables, dequeues, queues, stacks, strings, and vlists. One or more large arrays are sometimes used to emulate in-program dynamic memory allocation, particularly memory pool allocation. Historically, this has sometimes been the only way to allocate dynamic memory portably. Arrays can be used to determine partial or complete control flow in programs as a compact alternative to multiple if statements. They are known in this context as control tables and are used in conjunction with a purpose-built interpreter whose control flow is altered according to values contained in the array. The array may contain subroutine pointers that direct the path of the execution. Dimensional arrays. A one-dimensional array or single-dimensional array is a type of linear array. Accessing its elements involves a single subscript which can either represent a row or a column index. As an example, consider the C declaration int and array name 10. Syntax, data type, and array name of size of array. In the given example, the array can contain 10 elements of any value available to the int type. In C, the array element indices are 0 to 9 inclusive in this case. For example, the expressions an array of 0 and an array name of 9 are the first and last elements respectively. Multidimensional arrays. For a two-dimensional array, the element with indices I to j would have the address b plus c dot I plus d dot j, where the coefficients c and d are the row and column address increments respectively. More generally, in a k-dimensional array, the address of an element with indices I1, I2, Ik is b plus c1 dot I1 plus c2 dot I2 plus ck dot Ik. For example, int a of 3 of 2. This means that array has 3 rows and 2 columns and the array is of integer type. How can we store 6 elements that are stored linearly but starting from first row linear then continuing with second row? The above array will be stored as A11, A12, A13, A21, A22, A23. This formula requires only k multiplications and k additions for any array that can fit in memory. Moreover, if any coefficient is a fixed power of 2, the multiplication can be replaced by bit shifting. The coefficients ck must be chosen so that every valid index tuple maps to the address of a distinct element. Address of array 12, 3. The address of array 12, 3 can be calculated using row major order as address of ARR of 12, 3 equals 200 plus 4 of 4, 12 minus 1 plus 3 minus 1. Address of array 12, 3. Again, using column major order, address array of 12, 3 equals 200 plus 4 of 25 of 3 minus 1 plus 12 minus 1. Multiplication of two matrices. The multiplication of two matrices using array type C++ source code example. This program is to multiply two matrices. The program is extendable. Search. The search algorithm described next is called a sequential or linear search. Suppose that you want to determine whether 27 is in the list. The sequential search works as follows. First, you compare 27 with list 0, that is, compare 27 with 35. Because list of 0 not equal to 27, you then compare 27 with list 1, that is with 12, the second item in the list. Because list 1 not equal to 27, you compare 27 with the next element in the list, that is, compare 27 with list of 2. Because list of 2 equals 27, the search stops. This is a successful search. Let us now search for 10. As before, the search starts with the first element in the list, that is, at list of 0. This time, the search item, which is 10, is compared with every item in the list. Eventually, no more data is left in the list to compare with the search item. Sequential search function. Suppose that the name of the array containing the list elements is list. The following function performs a sequential search on a list. Insert. The function insert inserts a new item in the list. Because duplicates are not allowed, this function first searches the list to determine whether the item to be inserted is already in the list. To determine whether the item to be inserted is already in the list, this function calls the member function sequence search described previously. If the item to be inserted is not in the list, the new item is inserted at the end of the list and the length of the list is increased by 1. Also, the item to be inserted is passed as a parameter to this function. Insert. The function insert inserts a new item in the list. Because duplicates are not allowed, this function first searches the list to determine whether the item to be inserted is already in the list. To determine whether the item to be inserted is already in the list, this function calls the member function sequence search described previously. If the item to be inserted is not in the list, the new item is inserted at the end of the list and the length of the list is increased by 1. Also, the item to be inserted is passed as a parameter to this function. The definition of this function is as shown. Remove. The function remove deletes an item from the list. The item to be deleted is passed as a parameter to this function. To delete the item, the function calls the member function sequence search to determine whether the item to be deleted is in the list. If the item to be deleted is found in the list, the item is removed from the list and the length of the list is decremented by 1. If the item to be removed is found in the list, the function sequence search returns the index of the item in the list to be deleted. We can now use the index returned by the function sequence search and use the function remove at to remove the item from the list. Therefore, the definition of the function remove is as shown. Sparse polynomial representation and addition. Polynomial is an expression which is composed of terms, wherein terms are composed of coefficient and exponent. An example of a polynomial is 4x to the power of 3 plus 5x to the power of 2 plus 6x plus 9. This polynomial is composed of 4 terms with the following sets of coefficient and exponent: 4, 3, 5, 2, 6, 1, 9, 0. Thus, representation of a polynomial using arrays is straightforward. Sparse polynomial representation and addition. The subscripts of the array may be considered as exponents and the coefficients may be stored at an appropriate place referred to by the subscript. Example for array representation shown here. The representation works fine for the above example, but for the polynomials such as 5x6 plus 7, array representation is considered feasible on account of memory usage. Sparse matrix representation is shown here. For addition of two polynomials using arrays, subscript-wise elements may be added to result in the polynomial containing result of addition of two polynomials. Sparse polynomial representation and addition example. Polynomial 1, 4x to the power of 3 plus 5x to the power of 2 plus 6x plus 7. Polynomial 2, 3x to the power of 3 plus 4x to the power of 2 plus 2x plus 2. Array representation. Result. Example for program to represent two polynomials using arrays and compute their sum. Example for program to represent two polynomials using sparse matrix representation using arrays, compute sum of two polynomials and represent the result using sparse matrix. Stack implementation of array. Stack is one of the most important data structures that every computer programmer should be aware of. It follows the simple last in, first out principle. Implementation of stack can be done in many ways. One of the simplest way is using arrays. Here an array is initialized to a maximum value first. Let's call its capacity. As and when we push elements onto the array, its size will get increased. When the size reaches the capacity, we should ideally double the array size. Defining the stack class. The stack class is nothing but the array declaration. Private and public classes are declared. Push operation. The push operation is used to insert the element in the array. Pop operation. The pop operation is used to delete the element in the array. Check the element is empty. If the element is empty, we can't do pop operation. Queue implementation using array. Queue operations are implemented using array of size 5. Queue operations are: enqueue, insert an element at rear end; dequeue, delete element from front end; NQ operation in queue. NQ is used to insert the elements in the queue. DQ operation in queue. DQ operation is used to delete the element in the queue. Stack using linked list in C++ and implementation. Stack is an abstract data type and a data structure which follows last in first out principle. We have also seen the advantages of stack data structure. Why to implement stack using linked list rather than arrays? Stack implementation using an array, the size of the array needs to be fixed to store the values in the stack. If the stack is full, we cannot insert an additional element into the array. It gives an overflow exception. But in linked list, we can increase size at runtime by creating a new node. So it is better to implement stack data structure using linked list data structure. The following are the operations to implement stack: insertion, deletion, display element. Insertion operation. Insertion operation refers to inserting an element into stack. Create a new node and insert an element into the stack. To follow the stack principle, last in, first out. A node needs to be created from the end of the linked list and element needs to be inserted into the node from the end of the linked list. Deletion operation is to delete an element or node from the linked list. Deletion can be done by deleting the topmost element from the stack, as the last element inserted is the first element that needs to be deleted as per stack principle. So the recently inserted element, that is, top element, must be deleted from the linked list to perform as stack deletion. Circular linked list. Circular queue is a linear data structure. It follows first in, first out principle. In circular queue, the last node is connected back to the first node to make a circle. Circular linked lists follow the first in, first out principle. Elements are added at the rear end and the elements are deleted at the front end of the queue. Both the front and the rear pointers points to the beginning of the array. It is also called as ring buffer. Items can be inserted and deleted from a queue in O of 1 time. Circular linked list. Circular queue can be created in 3 ways. They are using single linked list, using double linked list, using arrays. Using single linked list. It is an extension for the basic single linked list. In circular linked list, instead of storing a null value in the last node of a single linked list, store the address of the first node root, forming a circular linked list. Using circular linked list, it is possible to directly traverse to the first node after reaching the last node. Using double linked list. In double linked list, the right side pointer points to the next node address or the address of the first node, and left side pointer points to the previous node address or the address of the last node of a list. Hence, the list is known as circular double linked list. Algorithm for creating circular linked list. The algorithm steps show the creation of a circular linked list. Step 1. Start. Step 2. Create a node with the following fields to store information and the address of the next node. Structure node. Begin. int info. Pointer to structure node called next. End. Step 3. Create a class called CList with the member variables of pointer to structure nodes called root, previous, next, and the member functions create to create the circular linked list and display to display the circular linked list. Step 4. Create an object called C of CList type. Step 5. Call C, create member function. Step 6. Call C, display member function. Step 7. Stop. Algorithm for create function. The algorithm steps show the create function in circular linked list. Step 1. Allocate the memory for new node. New node equals new of node. Step 2. New node next equals new node dot / circular. Step 3. Repeat the steps from 4 to 5 until choice equals n. Step 4. If root equals null, root equals previous equals new node / previous is a running pointer which points last node of a list. Else, new node next equals root. Previous next equals new node. Previous equals new node. Step 5. Read the choice. Step 6. Return. Algorithm for display function. The algorithm steps show the display function in circular linked list. Step 1. Start. Step 2. Declare a variable of pointer to structure node called temp. Assign root to temp. Temp equals root. Step 3. Display temp info. Step 4. Temp equals temp next. Step 5. Repeat the steps 6 until temp equals root. Step 6. Display temp info. Step 7. Temp equals temp to next. Step 8. Return. Using array. In arrays, the range of a subscript is 0 to n-1, where n is the maximum size. To make the array as circular array, by making the subscript 0 as the next address of the subscript n-1 by using the formula subscript equals subscript plus 1 percentage maximum size. In circular queue, the front and the rear pointer are updated by using the formula subscript equals subscript plus 1 percentage maximum size. Algorithm for NQ operation using array. Step 1. Start. Step 2. If front equals of rear plus 1 percentage max, print error circular queue overflow. Step 3. Else rear equals rear plus 1 percentage of max. Queue of rear equals element. If of front equals -1, f equals 0. Step 4. Stop. Algorithm for DQ operation using array. Step 1. Start. Step 2. If of front equals rear and of rear equals -1. Print error circular queue underflow. Step 3. Else element equals queue of front. If front equals rear, front equals rear equals -1. Else front equals front plus 1 percentage max. Step 4. Stop. Priority queues. A priority queue is an abstract data type that captures the idea of a container whose elements have priorities attached to them. An element of highest priority always appears at the front of the queue. If that element is removed, the next highest priority element advances to the front. The C++ standard library defines a class template priority queue with the following operations. Push. Insert an element into the priority queue. Top. Return, without removing it, a highest priority element from the priority queue. Pop. Remove a highest priority element from the priority queue. Size. Return the number of elements in the priority queue. empty, return true or false according to whether the priority queue is empty or not. Priority queue for integers. Example for priority underscore queue for integers. Priority queue with the smallest value at the front using a predicate. Example for a priority underscore queue with the smallest value at the front using a predicate. Priority queue separation. Example for priority underscore queue of integer top, pop, empty. Priority queue pop operation. Example for priority underscore queue pop. Application of stack. The following are the application of stack: parsing, recursive function, calling function, expression evaluation, expression conversion, integer fix to postfix, integer fix to pretfix, postfix to integer fix, pretfix to integer fix. Towers of Hanoi. Evaluating a postfix expression. Algorithm to evaluate postscript expressions. 1. Initialize an empty stack. 2. Repeat the following until the end of the expression is encountered. A. Get the next token, constant, variable, arithmetic operator in the postfix expression. If the token is an operand, push it onto the stack. If it is an operator, then do the following. Pop the top two values from the stack. If the stack does not contain two items, an error due to a malformed postfix expression has occurred and evaluation is terminated. Apply the operator to these two values. Push the resulting value back onto the stack. When the end of the expression is encountered, its value is on the top of the stack. In fact, it must be the only value in the stack, and if it is not, an error due to malformed postfix expression has occurred. Evaluating a postfix expression. 1. Scan the expression from left to right. 2. If an operand is seen, push it onto stack. 3. If an operator is seen, pop off the top two elements operands x and y from stack and perform z equals x operand, y, push z onto stack. 4. Repeat steps 2 and 3 till scanning is over. Pointers. What are pointers? A pointer is a variable whose value is the address of another variable. Like any variable or constant, you must declare a pointer before you can work with it. The general form of a pointer variable declaration is: here, type is the pointer's base type. It must be a valid C++ type, and variable name is the name of the pointer variable. Using pointers in C++. When the code is compiled and executed, it produces result something as follows. Arithmetic pointer. As you understand, pointer is an address which is a numeric value. Therefore, you can perform arithmetic operations on a pointer just as you can a numeric value. There are 4 arithmetic operators that can be used on pointers: plus plus, minus minus, plus and minus. To understand pointer arithmetic, let us consider that PTR is an integer pointer which points to the address 1000. Assuming 32-bit integers, let us perform the following arithmetic operation on the pointer. PTR plus plus. The PTR will point to the location 1004 because each time PTR is incremented, it will point to the next integer. This operation will move the pointer to next memory location without impacting actual value at the memory location. If PTR points to a character whose address is 1000, then above operation will point to the location 1001 because next character will be available at 1001. Incrementing a pointer. We prefer using a pointer in our program instead of an array because the variable pointer can be incremented, unlike the array name which cannot be incremented because it is a constant pointer. The following program increments the variable pointer to access each succeeding element of the array. When the code is compiled and executed, it produces the result something as follows. Pointer comparisons. Pointers may be compared by using relational operators such as equal to, greater than and lesser than. If P1 and P2 point to variables that are related to each other, such as elements of the same array, then P1 and P2 can be meaningfully compared. The following program modifies the previous example 1 by incrementing the variable pointer so long as the address to which it points is either less than or equal to the address of the last element of the array, which is AND variable of max minus 1. When the code is compiled and executed, it produces a result something as follows. Incrementing a pointer. Before we understand the concept of array of pointers, let us consider the following example, which makes use of an array of 3 integers. When the code is compiled and executed, it produces the following result. Incrementing a pointer. There may be a situation when we want to maintain an array which can store pointers to an integer or character or any other data type available. Following is the declaration of an array of pointers to an integer. This declares PTR as an array of max integer pointers. Thus, each element in PTR now holds a pointer to an integer value. Following example makes use of 3 integers which will be stored in an array of pointers as follows. When the code is compiled and executed, it produces the following result. Linked list. To overcome the limitations in array, we can store the data in randomly used linked list. The main advantage of linked lists over arrays is that the links provide us with the capability to rearrange the item efficiently. This flexibility is gained at the expense of quick access to any arbitrary item in the list because the only way to access to an item in the list is to follow links from the beginning. Singly linked list. A linked list is a series of nodes in memory such that there is a starting node. Each node contains a pointer that points to the next or child node. If a node does not have a child node, then its pointer is set to null. Each node contains data, maybe a lot of it. The linked list also has functions that manage the list by performing additions, deletions, changing the data of a node, returning the number of nodes, etc. Traversal algorithm. Step 1. Beginning from the head. Step 2. Check if the end of a list hasn't been reached yet. Step 3. Do some actions with the current node which is specific for particular algorithm. Step 4. Current node becomes previous and next node becomes current. Go to the step 1. Assume that we have a list with some nodes. Traversal is the very basic operation which presents as a part in almost every operation on a singly linked list. For instance, algorithm may traverse a singly linked list to find a value, find a position for insertion, etc. For a singly linked list, only forward direction traversal is possible. Singly linked list, addition, insertion, operation. Empty list case. When list is empty, which is indicated by head equals null condition, the insertion is quite simple. Algorithm sets both head and tail to point to the new node. Add first. Case 1. In this case, new node is inserted right before the current head node. Case 2. It can be done in 2 steps. 1. Update the next link of a new node to point to the current head node. 2. Update the head link to point to the new node. Add last. Case 1. In this case, new node is inserted right after the current tail node. Case 2. It can be done in 2 steps. 1. Update the next link of the current tail node to point to the new node. Update tail link to point to the new node. General case. Case 1. In general case, new node is always inserted between 2 nodes which are already in the list. Head and tail links are not updated in this case. Case 2. Such an insert can be done in 2 steps. 1. Update link of the previous node to point to the new node. 2. Update link of the new node to point to the next node. Singly linked list. Removal, deletion operation. List has only one node. When list has only one node, which is indicated by the condition that the head points to the same node as the tail, the removal is quite simple. Algorithm disposes the node pointed by head or tail and sets both head and tail to null. General case. Case 1. In general case, new node is always inserted between 2 nodes, which are already in the list. Head and tail links are not updated in this case. Case 2. Such an insert can be done in 2 steps. Step 1. Update link of the previous node to point to the new node. Step 2. Update link of the new node to point to the next node. Singly linked list. Removal, deletion operation. List has only one node. When list has only one node, which is indicated by the condition that the head points to the same node as the tail, the removal is quite simple. Algorithm disposes the node pointed by head or tail and sets both head and tail to null. Remove first. Case 1. In this case, first node, current head node, is removed from the list. Case 2. It can be done in 2 steps. 1. Update head link to point to the node next to the head. 2. Dispose removed node. Remove last. Case 1. In this case, the last node, current tail node, is removed from the list. This operation is a bit more tricky than removing the first node because algorithm should find a node which is previous to the tail first. Case 2. It can be done in 3 steps. Step 1. Update tail link to point to the node before the tail. In order to find it, list should be traversed, first beginning from the head. Step 2. Set next link of the new tail to null. Step 3. Dispose removed node. General case. In general case, node to be removed is always located between 2 list nodes. Head and tail links are not updated in this case. Such a removal can be done in 2 steps. Step 1. Update next link of the previous node to point to the next node relative to the removed node. Step 2. Dispose removed node. Linked stacks and queues. Stack. What is stack? Stack is a linear data structure which implements data on last in first out criteria. Push. Push is used to insert operation. Pop. Pop is used to delete the element in stack. Example for program stack. Here is a C program to implement stack using linked list. Queue. Implement queue using linked list in C program. Queue is a data structure that uses first in first out principle. Queue can be implemented by stack, array, and linked list. Also see C++ program to implement queue using array. Enqueue to add the value in queue. Dequeue, delete the value in queue. Example for program queue. Polynomial representation and manipulation using linked list. A polynomial is an expression that contains more than 2 terms. A term is made up of coefficient and exponent. An example of polynomial is p of x equals 4x to the power of 3 plus 6x to the power of 2 plus 7x plus 9. A polynomial thus may be represented using arrays or linked lists. P of x equals 4x to the power of 3 plus 6x to the power of 2 plus 7x plus 9. Array representation assumes that the exponents of the given expressions are arranged from 0 to the highest value degree, which is represented by the subscript of the array beginning with 0. The coefficients of the respective exponent are placed at an appropriate index in the array. Addition operation in polynomial representation. Addition of 2 polynomials using linked lists requires comparing the exponents, and wherever the exponents are found to be same, the coefficients are added up. For terms with different exponents, the complete term is simply added to the result, thereby making it a part of addition result. Multiplication operation in polynomial representation. Multiplication of 2 polynomials, however, requires manipulation of each node such that the exponents are added up and the coefficients are multiplied. After each term of first polynomial is operated upon with each term of the second polynomial, then the result has to be added up by comparing the exponents and adding the coefficients for similar exponents and including terms as such with dissimilar exponents in the result. Circular linked list. Circular linked list is a more complicated linked data structure. In this, the elements can be placed anywhere in the heap memory, unlike array, which uses contiguous locations. Nodes in a linked list are linked together using a next field, which stores the address of the next node in the next field of the previous node. That is, each node of the list refers to its successor, and the last node points back to the first node, unlike a singly linked list. It has a dynamic size which can be determined only at runtime. Basic operations of a singly linked list are: insert, inserts a new element at the end of the list; delete, deletes any node from the list; find, finds any node in the list; print, prints the list. Insert. This function takes the start node and data to be inserted as arguments. New node is inserted at the end, so iterate through the list till we encounter the last node. Then allocate memory for the new node and put data in it. Lastly, store the address of the first node, start, in the next field of the new node. Delete. This function takes the start node as pointer and data to be deleted as arguments. Firstly, go to the node for which the node next to it has to be deleted. If that node points to null, that is, pointer next equals null, then the element to be deleted is not present in the list. Else, now pointer points to a node and the node next to it has to be removed. Declare a temporary node, temp, which points to the node which has to be removed. Store the address of the node next to the temporary node in the next field of the node pointer, pointer next equals temp next. Thus, by breaking the link, we remove the node which is next to the pointer, which is also temp. Because we deleted the node, we no longer require the memory used for it. Free will reallocate the memory. Find. This function takes the start node as pointer and data value of the node key to be found as arguments. A pointer start of type node is declared which points to the head node of the list. Node into star equals pointer. First node is dummy node, so start with the second node. Iterate through the entire linked list and search for the key. Until next field of the pointer is equal to start, check if pointer data equals key. If the key is found, else move to the next node and search pointer equals pointer next. If key is not found, return 0, else return 1. Print. Function takes the start node as start and the next node as pointer as arguments. If pointer equals start, then there is no element in the list. Else, print the data value of the node, pointer data, and move to the next node by recursively calling the print function with pointer next sent as an argument. Advantage. The advantage is that we no longer need both a head and tail variable to keep track of the list. Even if only a single variable is used, both the first and the last list elements can be found in constant time. Also, for implementing queues, we will only need one pointer, namely tail, to locate both head and tail. Disadvantage. The disadvantage is that the algorithms have become more complicated. Example, initially. In initially, the node value is 0. After adding value 2, the temp moves one step forward. Initially, the node value is in 2. After adding value 6, the temp moves one step forward. After adding value 1, the temp moves one step forward. After adding value 10, the temp moves one step forward. After adding value 8, the temp moves one step forward. Print. Printing the values. Delete. The value 1 is deleted from the circular. Find. The value 10 is found in the circular. Doubly linked list. A doubly linked list is a linked list in which every node has a next pointer and a back pointer. In other words, every node contains the address of the next node and every node contains the address of the previous node. Basic operations of a singly linked list are: insert, inserts a new element at the end of the list; delete, deletes any node from the list; find, finds any node in the list; print, prints the list. Default constructor. The default constructor initializes the doubly linked list to an empty state. It sets first and last to null and count to 0. Empty list. This operation returns true if the list is empty, otherwise it returns false. The list is empty if the pointer first is null. Destroy the list. This operation deletes all the nodes in the list, leaving the list in an empty state. We traverse the list starting at the first node and then delete each node. Furthermore, count is set to 0. Initialize the list. This operation reinitializes the doubly linked list to an empty state. This task can be done by using the operation destroy. The definition of function initialize list is as follows. Length of the list. The length of a linked list, that is, how many nodes are in the list, is stored in the variable count. Therefore, this function returns the value of this variable. Reverse print the list. This function outputs the information contained in each node in reverse order. We traverse the list in reverse order starting from the last node. Its definition is as follows. Stacks. A data structure in which the elements are added and removed from one end only. A last in, first out data structure. Now that you know what a stack is, let us see what kinds of operations can be performed on a stack. Because new items can be added to the stack, we can perform the add operation called push to add an element onto the stack. Similarly, because the top item can be retrieved and or removed from the stack, we can perform the operation top to retrieve the top element of the stack and the operation pop to remove the top element from the stack. The push, top and pop operations work as follows. Suppose there are boxes lying on the floor that need to be stacked on a table. Queue. A data structure in which the elements are added at one end, called the rear, and deleted from the other end, called the front. A first in, first out data structure. Conclusion. Thus, we learned about basics of C++, elementary data structures, arrays, linked lists, and the following in detail. Basics of C++, object-oriented programming, representation of arrays, application of arrays, stacks and queues, application of stacks, pointers, linked list.